So now that you have all of your hash marks in place, now you want to double check. So count them up, make sure that you have 35, which is the number of total respondents, and that's kind of your check to make sure that everything's accurate. So once you have the hash marks, you're going to go through and count the number that you have and then put that number in, because we don't need the hash marks, we need the actual number. So in this one we have 1, 2, 3, 4, 5, 6, 7. And we have 1, and then in this box we have 2, and then 2, 2. This one we have 1, 2, 3, 4, 5, 6, 5, 3, 1, 0, 3, and 3. So again, if you add those up, you should have 35. So let's see, we have 10, 17, 20, 25, 27, 30, 35. So then in our total down here, we're going to have 10, 7, 10, and 8. And then our totals across here, we're just going to add up across. So 7 plus 1 plus 2 plus 2 is 12. And then we have 16, and we have 7. And then when I add all of those up both directions, I should have 35 every way. So now come the column percents. And so I'm going to take the number that's in this box, the 7, and I'm going to divide by the column total, 10. So 7 divided by 10 is 70%. It's 0.70. We multiply that by 100 to get our percentage. We go down, 2 divided by 10 times 100 is 20%. 1 divided by 100 is 10%. And so we're going to go to 2 decimal places. These don't have any decimals, so that makes it easy. And then we get some more complicated ones. Dividing by 10 is easy. Dividing by 7 is a little more tricky. So 1 divided by 7 is going to give us 14.29%. Let's see, 6 over 7 is going to be 85.71. And then 0 over 7 is going to give us 0%. And then we have a nice another even 1 out of 10. So we're going to have 2 out of 10 is 20%. 5 out of 10 is 50%. 3 out of 10 is 30%. And then we come to our last one, and we're going to have over 8. So 2 out of 8 should be 25%. And then 3 out of 8 is 37.5%. And we have another 3 out of 8, so 37.5%. And then we have over here in our totals, we have 12 out of 35, which is 34.29. And then we have 16 out of 35, 45.71. And then this should be a nice even 20%, I think. Yes, 20%. And so that should, all of these should equal 100%. So now you've got your crosstab constructed. It is done, and now the trick is interpretation. So let's talk a little bit about how you would interpret your crosstab. Let's go back to our PowerPoint. So we need to find the patterns in the contingency table or in the crosstab. And the best way to kind of start understanding the nature of the association or the relationship between these variables is to start with a hypothesis. Know what you're looking for by clearly stating the hypothesis. And then any of your interpretations for the crosstab should link the independent and dependent variables. So here's another example that we can interpret. So here we have, is life exciting or dull by respondent's sex. So the independent variable is respondent's sex, and the dependent variable is life exciting or dull. So for this one, we might have a hypothesis that states that maybe men are more likely, or males are more likely to find life exciting than women. So what we would do is we would go through and circle the highest percent in each row. So going across the categories of the dependent variable and circling the highest percents. And so what that does is it shows us that relationship. So what we can see here is that 50.1% of males find life exciting as compared to 39.8% of females. And then if you look at the category of dull, you'll see that women or females find life dull about twice as often as men. So this would seem to support our hypothesis. The way I would write that out is I would write this. Males were more likely than females to say that life was exciting, 50.1% as compared to 39.8%. Also, women were nearly twice as likely to report that life was dull, with 5.2% compared to 2.8% for men. Together, these data seem to support our hypothesis that men are more likely to find life exciting. So again, it supports our hypothesis. We didn't prove anything. There's no causation here, but we do find support for the hypothesis. So what about variables that have order? So for example, in our written example, the one that we just created, you have two variables that are ordinal. So you have age categories, and then you have kind of that liker item that's an ordinal. So in here, part of our interpretation is going to have to do with a direction of the association. And so what we're talking about is whether an increase or decrease in the value of one variable, at this point we're talking about the independent variable, is associated with an increase or decrease in the value of a second variable, our dependent variable. This is what we call a linear association. So to find a linear association, we're going to circle the highest one or two percentages in each row and then look at the relationship that we see. So I say highest one or two because it depends on the size of your table. If you have a lot of categories in your independent and dependent variables, you'll want to circle the highest two percentages. If it's not a very large table, then you'll just want to circle the one highest percentage. So let's look at an example and what that would look like. So there are two different types of linear associations. There are positive linear associations and then negative associations. So in a positive association, as the value of the independent variable goes up, so again, independent variables across the top, and it goes up from 1 to 3, so this direction, the values on the dependent variable also go up from 1 to 3, this direction. So the x's are the highest percentage in that row. And so you can see that those x's are going up. And so we've got this line that kind of goes this direction. And that would indicate a positive linear relationship. On the other hand, a negative linear relationship is when, as the value of the independent variable goes down from 3 to 1, the value of the dependent variable goes up from 1 to 3. And so you have, again, the x's mark the highest percentage, and you can see that they're going in a line this direction. And so so we have a negative relationship here. So here's another example using some SPSS output. So here our variables are respondent's highest degree and then their subjective social class. So let's go ahead and we will circle the highest percentage in each row. And we're just going to circle the one highest, and then we'll go back through and we'll see if it's any different if we circle the two highest. All right, so we see that it does seem to be heading that direction. It's not the clearest line, but we can see that those with a lower degree tend to be in the lower classes, and those with higher degrees make up more in the higher classes. So let's go ahead and circle the second highest in each. So we have 7.3, then 49.8, and then over here. And so when we do that, you can kind of connect the dots and you can see a positive linear relationship. Again, we don't know how strong this is. We don't know if it's statistically significant. That's all things that we will talk about next week when we talk about measures of association and chi-square. But for now, it looks like there's some sort of relationship. So in the real world, most associations are not necessarily linear. These are what we call curvilinear relationships. We're not going to cover these in this class, but it's good for you to know that they exist. So curvilinear relationship, when you circle the highest, it might look like a boomerang, going either direction. And there are ways statistically that we can handle these relationships and test them. But again, that's for another class for grad school. So that's all we're going to cover in this section. Stay tuned for the next video where we're going to talk about SPSS and then also measures of association and chi-square.